Hello, my name is Kell Geisler, and today we're going to be learning about linear and nonlinear regressions, as well as the Antoine equation. Um, and we are going to be applying this to water vapor pressure with values obtained from GitHub. So to start, let's go obtain those values. This is our water vapor pressure data and our X and Y values that we're going to be using. We're going to obtain the raw file and copy the URL. We're going to say you get giving us our values. So this will give us our water vapor pressure values. You say Shift Enter, shows it's working, and then we'll look at our files. We see our water vapor pressure file right there, and now we're going to start with the plotting of this data, which is going to be import numpy as np, and after that we are going to state that we want to make our subplots. So from plotly dot subplots, and we're going to import make subplots to make our subplot. Next, what we're going to do is load in our text, or load in our data that we've been given. So we have X as our temperatures, and then the Y is our vapor pressure, and these have to be separated by commas. So we're going to say data equals load txt np. You say np for it. If you load our text, and then we're going to state that it's our water vapor pressure .csv. That's the name of the file. And then we're also going to add a delimiter to indicate that our values are separated by commas. So what happened is I already made my first mistake. That it looks like. So the period goes between the NP and the load, I believe. And then the delimiter should be separated by commas. Here we go. And that should be a lot better. And then we'll add a new line. So now what we have to do is assign values to our data points. So T is going to be our temperature. That's going to be our X value. So that will equal data on the first value, which is going to be 0. And then the log of P, which is going to be our pressure, Y value, is going to equal our NP log base 10, which we got from the Antoine equation, as 1, the value 1. Next, what we're going to do is start to plot our data, and want it to look a little better, so I'm going to make it into a darker plot. And so we're going to say import plotly .io as PO, and we're going to turn it into dark by saying PIO dot default or templates default equals plotly. All right, so now we need to graph this. And to graph this, we are going to make our plots. So we're going to say fig equals make subplots, and we're going to determine our rows and columns. So rows, one row, and columns, one. And then we are going to determine, we're going to make a scatter plot. We're going to add a scatter plot, and we're going to say fig.scatter, add scatter, fig add scatter, and then we're going to do our x value, which is going to be our t, and our y value, which is going to be our log of p. We also need to state that our mode is going to be so what I meant to say was the mode is going to be markers, and that our name will be equal data. That should be how we shift enter. Looks like we put an end parenthesis. Make subplots is not defined. Okay. Maybe I spelled something wrong. Make underscore subplots should be right here. Make underscore subplots. Oh, this needs a underscore. Okay. There's some invalid syntax in here. Delimiter. Invalid syntax right here. I'm not sure what it is though. Delimiter equals. Time. All. Okay. Zero is correct, but it's looking at numpy new function object is not subscriptable. Okay. Not 100% sure how to fix this one. So what I'm missing is some parentheses and data. So you have to state that this is going to be the data. And then this needs to be a little syntax mistake. This should be calls. And then let's try to run it now. There we go. And here is our first scatter plot. And this looks fairly accurate as 10.5 in thousands of pascals. That's fairly accurate to the boiling point. And this should be fairly accurate. But we want to make it a little more close together, a little less wide. So we're going to change the width. So we're going to try to make this a little less wide. And what we're going to do is we are going to change the height and the width of our plot. And so we're going to say fig update layout. And that is going to be equal to height equal to 600, and the width is going to be equal to 800. Should be. And shift enter. Yeah, that's more of what we would like to see. So what we're doing here is we have our graph, a lot of different points on the scatter plot, right? And we've drawn a line through the middle. And what we want want to do is get each of these points closer to the graph. And the way we're going to do this is by making what's called a sum square error. And what this is going to do is take these small derivatives from the graph, deviations from the graph, and make them closer to the graph, or to the line that we've made, the regression. And the way we're going to do this is by making a sum squared error. By taking the Antoine equation, which is log P of your pressure equals A minus B over T plus C. And what we're going to do is make a sum squared error. So we're going to take the sum, n, we're going to take the sum of this, and say log P subtracted by our A minus B over T plus C. So what we're going to need to do is square this to make all those deviations positive. So we square that. And this is what's going to get us those deviations. We're going to add up all those deviations, get them closer to the graph. And what this sum squared error is going to depend on is changing A, B, and C and getting different test values for those. And we'll see how to do that later. So now what we're going to do is we are going to make our sum squared error in the code. So we're going to say def sum squared error of the v, of the vector, and then we're going to find our a, b, and c, which we're going to be changing. We're going to set those equal to the v. And then we're going to return the sum of whatever it is that we're taking, which right now is the Antoine equation, of log p, our sum equation that we just wrote down, minus a divided by a minus b divided by, put in parentheses, t plus c, and then that whole thing has to be squared. So we need to do it by here, squared. Yes. Yes, the whole. So now we are going to add our nonlinear regression values and try to plot this sum squared error. And so that's going to be A from the nonlinear regression, and then B from the nonlinear regression, and then C from the nonlinear regression. And this is going to be minimized by the minimize function. We're going to minimize our sum squared error. This, and then we're going to have our guess values. So these are going to be 1, 1, and 0 should be. Now what we're going to do is add another line, and we're going to add another scatter plot to see the sum squared error. So we're going to say fig add scatter, and then we're going to do our independent and dependent variables. So it's going to be x, c, which is our independent, and then y equals the a of the nonlinear regression minus b of nonlinear regression divided by t plus c. Oh wait, c of the nonlinear regression. That should be nonlinear regression. Yeah. Is that enough? And we're going to have mode as lines, and the name is going to be our Antoine nonlinear. I'm just going to say nonlinear. And we're going to say shift enter. And we've got some issues here. Can't assign a function to call. Okay. Scatter. Mode lines. Oh, an extra here. Invalid syntax. Okay. I think we have too many. 1, 2. I think we have enough. Okay. ANL is not defined. A of the nonlinear regression is not defined. A underscore NL. ANL is not defined. Let's see. So what I have to do to fix this, the name minimize is not defined. This is what is wrong. I have to import from the SciPy website that we found the minimize function on. So we say from SciPy optimize, we import our minimize function that was not defined earlier. So let me say runtime, restart and run all. This should give us 2 separate graphs. So very simple mistake here. Looks like I just spelled optimize wrong. Optimize. And then you run all. Should work. So here's our original graph, and here's our nonlinear regression. Yes. And our test values weren't fantastic, but they still fit the line, as you can see. But we can still do a little bit better. So now what we have to do is turn this nonlinear regression into a linear regression. And we're going to start by multiplying by t plus c. So that's going to multiply by our log p on one side, and then by our a plus b, or a minus b. And then we're just going to multiply out. So it's going to turn into our log p equal a times t, or sorry, t log p, up the front, t log p times our at. That's going to be multiplied by, sorry, that's going to be subtracted by our c log log p, and then that's going to be added to ac minus b. And we have this ac minus b. This is just a constant that we are going to turn into a d, as you can see. So you have your t plus c on both sides. This takes it into 8 times t minus c log p plus ac minus b. And that's just going to turn into our variable d. Now we're going to make our matrices, which our first one should be just our t1 and then minus log p1 and then just a row of 1s. We're going to have t2 minus log p2 all the way down to tn log pn. And we're going to multiply that by a, c, and d here. And that is going to equal us just t1 log p1 down to tn log pn. And this is going to be our x, this should be our y, and this is going to be our b vector. So now what we need to do is take that design matrix we just made and implement that using the inverses and make a more accurate linear regression on the graph. And so we're going to say x is going to be equal to our c. That's going to be times our t value, our negative log of p, just like the design matrix we just did, and np one's like t, because we want the row of ones that's going to be the same amount as t, because t is going to be t of n. And then we are going to add more code. And now we're going to do the same thing as above, but use the linear regression and not the non-linear regression. So we're going to say A of linear regression, C of linear regression, and we're going to use our D value as well. Instead of A, B, and C, we're going to use A, C, and the new D value we've just made. We're going to say linear algebra, LG, and take the inverse of the design matrix, and the @ sign multiplies matrices together. We're going to multiply that, take the inverse of that, and multiply it by the design matrix again, and then multiply that by the end of it, so the t log of p, and that should be okay. And now we are going to go into defining why that d is located there, and what the b has now turned into. So the b of linear regression is now equal to the a of linear regression, and that should be equal to the c of linear regression minus the d. Okay, now we're going to add another line of code that's going to add our second or our last linear regression scatter plot. So it's going to be a more accurate line. So we're going to say fig add scatter. There we go. Add scatter. And our x is going to be our new t plot. So t plot. And then our y is just going to be our same Antoine equation, but with the t plot. So it's going to be a and the linear regressions. A of linear regression minus b, and then you divide by t plot plus c of the linear regression, c of the linear regression, and then our mode is going to be equal to lines, and then our name should be equal to Antoine, just like we had up top, Antoine of the linear regression, and not the non-linear regression. So let's try to do a runtime, restart and run all. See if this works. And so what we need to do is I added a LR, the linear regression to the B, and then a parenthesis towards the end, and fix that up. And it's telling me that I need to name my t-plot, and I've not defined it. So let's go up and define our t-plot and give it its parameters. So t-plot is equal to line space, should be np. We give it a minimum, a t, and then max t, and then 100 data points. So let's see if that. So let's restart and run all, see if we have any mistakes. So we do. So there's got to be. Oh, here we go. Yeah, here's our second one. Here's our linear regression, and it looks like our guesses might not be as good because our line is all the way up here. So let's go ahead and fix that. So I've realized where my mistake was made, and it was right here. So I accidentally put an equal sign. This is a multiplication. So it's B linear regression equals A times C minus D. And what we need to do with this now is figure out what values we need to do. We need to put in up top what we need to guess. And so let's run, restart and run all. Should be good. And now we have some better numbers to guess with. So we have 10, 1,771, and again, the negative 34. So let's go change those. Yes, here. 10, 1,771, and then negative 34. So now we have our linear regression down here, and then we should have another. We have our linear regression down here, and this, it might look the same, but if you zoom in, you can see they are very much different. Oh, you gotta see when you zoom in. That's right. Zoom in, you can see these lines are very much different paths, and the linear regression would be more accurate. So thank you for watching. I hope all of this was very beneficial to learning about linear regressions, nonlinear regressions, and minimizing functions. So thank you.